Welcome to Academic Digest class. A 3.0 microfarad capacitor is charged by a 12 voltage battery. It is disconnected from the battery and then connected to an uncharged 7.0 microfarad capacitor. Determine the total stored energy. A, before the two capacitors are connected, so then B, after. So this is the question. Let's solve. So let me write out the things. They gave me 3.0 farad capacitor, that is C1. It's connected to 12V battery. It is voltage given. So V1, or let's say voltage, it's just one they give us. It is disconnected from the battery and then connected to an uncharged C2. Uncharged 7 microfarad C2. So they said we should determine the total stored energy before the capacitors are connected. So this is the sentence saying, I remember that Q is equals to CV. So, and I remember that if that is the case, the charge here, the charge that will be here will be equals to Q equals to 3 times 12. I'm not converting my microfarad. If you want, you can convert your. If you want to convert, you just do times 10 raised to the power minus 6. Okay, not convert. So you have 3 times 12 is equals to Q is equals to 36. That means it will be in microcoulomb. Since our value is equal to microcoulomb for Q, and that is our Q1 because this is C1. So Q1 is equals to this. But what they asked us is to find energy stored. So A, energy stored before the two capacitors are connected. So energy stored before the two capacitors are connected is equals to energy when 12V battery was connected, or you say energy in charging the capacitor C1. So that will be the same thing as saying E equals to, we have Q, and we know that energy stored can be given by half Q square over C. That is when we have charge and we have capacitance, and it can also be given by half CV square. It can also be given by half QV. I'm giving you this from my head. That's the way you should know it too. So I want to use this one. Assuming they said by parallel plates, I will not think of that other one. That is C equals to E naught A all over D. So but this one now I'll use half, since I have Q here. Q is 36. So let me do 36 square divided by the first capacitance. Yes, now the first capacitance is 3. So divided by 3. If you put it here, you still get the same thing. So I will now have 36 square is equals to, this is equals to 1296 divided by 3, then multiply by half. So divided by 3 is equals to, so I have half 432. So if I do this divided by 2, I now get E is equals to 216 joules. So if you want to know if you are correct, you can say V is actually 12, right? And C is 3, then half. So you do 12 times 12, 144 times 3, 432 divided by 2. You get the same thing. So if you use this, you still get the same thing. So I don't like situation where we have to cram. So once we just know it, we need to go back and watch the video I made for the 3 formulas for energy stored in a capacitor. So if I know this, I can now move to the B part. So total energy stored after they are connected. So the total energy stored after the two capacitors are connected is now for you to check. Okay, so if we have watched this question, so you see if it's in series or in parallel, you have a capacitor being charged by a battery. Let's say this is the capacitor. Let's say we have this capacitor now being charged by a battery 12V and then 3 microfarad. Then they are now telling us in the question that the voltage, the battery was removed, so it is disconnected from the battery, then connected to an uncharged 7.0 microfarad capacitor. So it's more like they now remove this voltage now, and you now have this way. So it's in parallel. So you have 3 microfarad, and then you have 7 microfarad. So if you know this one now is being used, discharged to charge this one. So they are in parallel. So that means that this will simply be the same thing as saying that we now have a capacitor. We know that capacitors in parallel. This is why we know that they are in parallel, because the battery was removed and they plugged this one. So if this is the case, we can now say that 3 plus 7 is 10. So 10 microfarad is what we have as the total capacitance. So for that reason, I can now go back to the B part. So B will now be E is equals to half Q square over C, which is the same thing as saying half Q square over C is the same thing. So it will be the same thing as saying half, then the charge I have, the total charge I have, if you remember, because they said that this 7 microfarad does not have any charge. If you read the question, it says connected to an uncharged, so it has no charge. For you to start saying you are using the capacitance, the 10 times this, and notice that there is no voltage there. So what is actually doing the work? No voltage, is this one that is doing the work. We're reading this question, so you know, is this one that is like functioning as a battery now and is being discharged. You know that energy stored in a capacitor is equal to the energy or equals to the work done in charging it. So in charging the capacitor. So this is the one supplying to this one. So that's the charge, the one that has charge. So for that reason, we'll use the charge we got for the first one, which is what did we get as the charge that time? 36 microcoulomb. Remember, we solved this. Solving for Q. Solving for Q, we got this. So we'll simply do E equals to half. Okay, we'll have it here. Half 36 square all over the new capacitance, which is 10. So 36 square, we got it to be 1296 divided by 10. So if you divide by 10, you have this to be half 129.6. So if you divide by 2, you have E to be equals to 64.8 joules. Very important to note. So you see it there, you have it. So that's your answer. That's your answer. So let's move to the second one. Let's move to the second question. So the second question says a 1 microfarad capacitor is charged using a constant current of 10 microfarad of 10 microampere. Unit of charge is ampere, but here they give us microampere for 20 seconds. What is the energy finally stored by the capacitor? That is number 2. So let's do it. First, they give us capacitor. Always write what you are giving out. So number 2, they give us C1 equals to 1 microfarad. Using a constant current. So they give us current I to be equals to what's how many microampere? 10 microampere. Currents. And they give us time 20 seconds. A 1 microfarad capacitor is charged using a constant current of 10 microampere for 20 seconds. What is the energy finally stored by the capacitor? What is the energy? So E, we don't know. So if that is the case, let's come here and see something. We know that current is equals to charge, the rate of charge. So that means that charge will be equals to IT. So Q is equals to charge. Sorry, yes, Q is equals to current. And current here is 10 microampere, which is the same as saying 10 times 10 raised to the power minus 6. So, and 10 times 10 raised to the power minus 6 is equals to 1, 2, 3, 4, 5. Is equals to, this is equals to 1 times 10 raised to the power minus 5. This one is the same thing as saying 1 times 10 raised to the power minus 6 farad. And this one is in coulombs. It's in ampere. Are you okay? Charge is the one that is in coulombs. So if you put it together now, you have charge, current 1 times 10 raised to the power minus 5 times 20. So 1 times 10 raised to the power minus 5 times 20. So you get Q is equals to 1, 2, 3, 4. 2 times 10 raised to the power minus 4 coulombs. Yes, so we've gotten Q. So now that we've gotten Q, the next thing is to find the energy. So to find the energy, we need to remember that there's something like half Q square over C. Yes, if I want, I can find voltage. If I don't want to stress myself, I can say remember that Q is also equals to CV. So that to find V now, you do V equals to Q over C. If I want, I can do this way, so that I can use half CV square. But there's no need doing this since we are working with time. So I will just do this one to check if my answer is correct, but let me use this one. Once I have capacitance and charge, I can just do energy is equals to half Q square over C. Over C. I did this so you know that the half, the 2 is down. So E is equals to half, let me put Q now, 2 times 10 raised to the power minus 4. Using this is, sometimes you punch in the calculator, it will be misbehaving. All over 1 times 10 raised to the power minus 6. You can see that these two things, I can do in this is to get 10 raised to the power minus 4. If this is going up, division law, minus minus, it will become plus 6. There's minus, and because it's division, there's another minus. Minus minus is plus. So times 2 divided by 1 is 2. Is it not? Yes, it is. So 2 divided by 1 is 2, yes. But something, I almost put myself in trouble. Notice something. This is all squared. This Q is squared. So before that, I should do minus 4 squared. 2 squared is 4. 2 squared is 4. Minus 4 squared should be 8. So 8 minus 8 minus 4 minus 4, it will be plus 8. Wait, so what are you doing? Wait, sorry. Yes, I'm coming. Let me do this. 2 times 10 raised to the power minus 4 times 2 times 10 raised to the power minus 4. Yes, that's it. Yes, it will be. Because it's negative, it will increase the negative. So it should be minus. So this should be minus 8. Minus 8, sorry. Minus 8. So if minus 8, then this one come up plus 6. Then divided by 1. So you see, this will now be, then everything here divided by 2. If you don't know mathematics, sorry for you. Because we are doing physics. So 2 here 1, 2 here 2. So I now have 2 times 10. Minus is in the bigger number. So 8 minus 6 is 2. There's minus in minus 2. This is my answer. And it's in joules. To confirm if I'm correct, I will say Q over C. So let me do 2 times 10 raised to the power minus 4 all over 1 times 10 raised to the power minus 6. So I will now have this will be the same thing as saying 2 times 10 minus 4. 6 coming up, minus 6 coming up, it will be plus 6. So it will be equals to 2 times 10 raised to the power 2 for V. So for V. Now if we use E equals to half CV square, E will be simply equals to half C is 1 times 10 raised to the power minus 6. And E here, 2 times 10 raised to the power is the same thing as saying 200. So 200 square. If you do 200 square, you get 200 times 200 will give you 40,000. 40,000. Now 40,000 divided by these 2 will give you 20,000. Give you 20,000. Remember, I'm trying to confirm something. 20,000 times 1 times 10 raised to the power minus 6. I know somebody is swearing for me somewhere. Let's do it well. So if you do 20,000, that is 2 times 10 raised to the power 5, and then times 10 raised to the power minus 6. Is it not? Five, yes. So times 10 raised to the power minus 6. Do it. So let me do 2 times, sorry, 20,000 times 10 raised to the power minus 6. So it gives me the same thing. Do it. Do it. We are correct. So anyone you use, we are still correct. So I'm not using this one. So I don't have time. You gotta rank indices. So That means that my answer is option B. Option B is my answer. So option B. Option B. Option B. So let me move to number 3. Question 3. A 1000 microfarad capacitor, initially uncharged, is charged by a steady current of 50 ampere. How long will it take for the potential difference across the capacitors to reach 2.5 voltage? Okay, let's write out, since I told you, always write out what you are given. Don't stay in the question. Don't stay on the question and start answering it. So to answer that, I'll simply have number 3. C1 equals to 1000 microfarad. And to convert this to farad is the same thing as saying times 10 raised to the power minus 6. Then they gave me number 3. They gave me a steady current of 50 ampere. Current equals to 50 ampere. Then they said, how long will it take for the potential difference across the capacitors to reach 2.5 voltage? So they gave me voltage 2.5. Then they're asking me for time. So time equals to unknown, voltage, potential difference 2.5 V. So these are the things I'm given. So if I know this, first of all, this is the same thing as saying, this thing that I have here is the same thing as saying 1 times 10 raised to the power 3, 10 minus 6, which is equals to 1 times 10 raised to the power minus 3. Yes. So, becoming 1 times 10 raised to minus 3. Yes, because if you do 1000 times 10 raised to power minus 6, you will get the same thing. So if I know that, what did they ask me to find? Time. I need to remember. Remember, current is equals to rate of charge. That is the amount of charge flowing in a circuit at a particular time. How much of it is it fast or what is it low? It's called current. So if I know this, it simply means that if I want to find time, notice that they did not give me even charge, but I remember that charge is equals to CV. They gave me C and they gave me V, so I can say Q. Okay, so from Q equals to CV, Q will be equals to 1 times 10 raised to the power minus 3 times 2.5. So 1 times 10 raised to the power minus 3 times 2.5. That will give you Q to be equals to 2.5 times 10 raised to the power minus 3 coulombs. So if I know that, I can now go back and say, since I equals to Q over T, C will now be equals to I times Q, or IQ. So that means T equals to IQ, which is the same thing as saying T is equals to 2.5 times 10 raised to the power minus 3 times I, and I is 50 ampere. So that you now have 2.5 times 10 raised to the power minus 3 times 50. What are you doing? Yes, now. 2.5 times 10. So you have 0.125. You have 0.125. So T is giving me 0.125 seconds. Are you sure? What did you do? What am I doing? What am I doing? Look at this. Look at this. I think this is where we got it wrong. This is where we got it wrong. Look at this, please. I equals to Q over T. Which means that if I make T here, T will first of all come here. What are you even doing? T will come here and become IT equals to Q. So that T will now be equals to Q over I. What are you doing? God forbid. So T can never be this. What are you saying? So T from T equals to Q over I, we should be having that T is equals to 2.5 times 10 raised to the power minus 3 all over 50. I'm solving this kind of thing. You people are watching it, looking at me. That's saying anything. I want to fill 2.5 times 10 raised to the power minus 3 divided by 50. So T should be equals to 0. Sorry, that is 1, 2, 3, 4, 5. That is 5 times 10 raised to the power minus 5 seconds. And by the time you want to convert this thing that I'm seeing now is also equivalent to, if I do 5 times 10 raised to the power minus 5, and I know that, for example, 1 coulomb is equals to 1 million microcoulomb. So that means that 1 second is equals to 1 million microseconds. So times 10 raised to the power minus 6. Yes. What are you doing? Sorry. Yes. 1 second equals to, yes, 1 second equals to 1 million microseconds. Yes, so it should be 1 million. So microseconds. So if you do it, 6 minus 5 is going to be 1, and 1 raised to power. Yes. Yes. I'm coming. I'm trying to get. Yes. So it will now be the same thing as saying 5 times 10 raised to the power minus 5 plus 6, which is going to be 5 times 10 raised to the power 1, and anything raised to the power 1 is that. So 5 times 10 is 50 microseconds. So please learn how to do this, because sometimes you will finish, you might not see the answer that you are looking for. So just like this case, so it's option E, 50 microseconds. So option E. So let's move to the next one, number 4. Number 4 says, what is the capacitance C of a capacitor charged at a potential difference of 60 voltage whose quantity of charge is 3 times? So this one is very simple. They gave me C, gave me V, gave me Q. They're asking me for capacitance. So what I just need to do in this case is to say number 4. Q is equals to CV. So they gave me Q equals to, what did they tell me Q is? They gave me Q to be, please be reading. Q is equals to 3 times 10 raised to the power minus 4. 3 times 10 raised to the power minus 4 coulombs, comma, C, I don't know it. Then they gave me V to be. They gave me V to be 60 voltage. What is the capacitance of capacitor charged at potential difference of 60 voltage? Whose quantity of charge is 3 times 10 raised to the power minus 4 coulombs. So voltage 60 60 volts. So what I just need to do here is to make C subject of the formula. So I do divide both sides by V. So C will simply be equals to 3 times 10 raised to the power minus 4 all over 60. So I'll just do 3 times 10 yes. So 3 times 10 raised to the power minus 4 divided by 60. So I have 1, 2, 3, 4, 5, 6. So I have this to be 5 times 10 raised to the power minus 6. And since it's capacitor, it will be in farad. From microfarad, we have farad. So that is Shebi. So we got that to be farad, Shebi. So we don't have any answer in farad here, but notice that they gave us something in microfarad, and I know that 1 farad is equals to 1 million microfarad. So I said 1 farad is equals to 1 million microfarad. That means that if I have 5 times 10 raised to the power minus 6 farad x microfarad, if I cross multiply, I will have 1f x microfarad is equals to, this 1 million is the same thing as saying 1 times 10 raised to the power 6, yes, then microfarad times 5 times 10 raised to the power minus 6 farad. There is this here, there is farad here, farad will cancel farad because I'm looking for something in microfarad. So I now have 10 minus 6 indices. If this multiplication, if it is multiplication, add the powers. 6 plus minus 6 is minus 6, so it will become 0. Yes, it will become 6 minus 6, it will become 10 raised to the power 0. Then I now have 1 times 5 times this microfarad equals to the x microfarad, which means anything raised to the power 0 is 1. So I now have 5 microfarad equals to x. That means that it can also be the same thing as saying 5 microfarad, and that is option B. So option B. Option B. So let's move to the next question. Next question, they said 3 capacitors of capacitance 3 microfarad, 4 microfarad, and 6 microfarad are connected in series. What is the equivalent capacitance? So you need to note that capacitance in series, I've taught you this before. Number 5. So capacitance in series, it is simply given by 1 over C total equals to 1 over C1 plus 1 over C2 plus 1 over C3. They give us 3 capacitances, so it will be 1 over CT equals to, they gave me 3 microfarad, 4 microfarad. I'm reading number 5. 3, 4, and 6 microfarad. So 3, 4, and 6. So if I check this now to get the LCM, I'll simply come here and do, I have 3, I have 4, I have 6. 3 here, 1, 4, come down. 3 into 6, 2. 2 here, 1, 2, 1. 2 here, 1, 1, 1. 2 times 2, 4. 4 times 3, 6. 4 times 3, 12. Are you kidding me? So I now have 12 here. So 12 into this will be 4. 4 times 1, 4. 12 into this will be 3. 3 times 1, 3. 12 divided by 6 will be 2. So you see that I now have equals to 1 over CT. So by the time I do 4 plus 3 plus 2, that is 7, 8, 9. So 9 over 12 equals to 1 over CT. Cross multiply so that you now get CT9 equals to 12 times 1, which is 1. So divide both sides by 9, so that you now get the total capacitance, which is equals to, yes, something can go. 3 into 12 will give you 4. 3 into 9 is 3. So the total capacitance is in a ratio, which is 4:3. Is it microcoulomb they gave us? Yes. Sorry, microfarad. This is our final answer. But if you don't want to leave your answer to like this, you can punch it and put it in decimal. But like I always tell you, always check if the option is in fraction before moving to decimal. So there you have it, 4/3 microfarad, and is here. That is option A. So option A. Option A. So let's move to number 6 question. So please remember that you have to subscribe to my channel. And then remember that this is our class on energy stored in a capacitor. So problem class on energy stored in a capacitor. So for number 6, they said the capacitor stores energy. I've explained this in our first class. I will explain, I'll just give you the answer. The capacitor stores energy, and this energy is equal to the work done in option A in charging the capacitor. So number 6 is A. So we'll move to number 7. Number 7 says define capacitance and obtain an expression for the capacitance of a parallel plate capacitor. Define capacitance and obtain an expression for the capacitance of a parallel plate capacitor. That is number 7. So first of all, we need to know that anything capacitance, you know that capacitance is an attribute that capacitor exhibits, and capacitor is a device, a passive device, electronic device that stores charge. So I can say that capacitance is the ability of a device system especially or example capacitor to store charges when work is done in moving charges. If you don't say when work is done, you can say when electric, or you say giving electric potential. So electric potential is given. So you can say that capacitance, you normally say that is given as charge over voltage. Charge over voltage, and the units is farads. But in practical purposes, we have microfarad, the nanofarad, the picofarad, and even the millifarad. So you need to know it. So SI units is farads. So you need to know this. Notice I'm rushing this. So the B part of this question, I'm rushing it because I don't want it to be long. The B part says, okay, they said deduce an expression for the capacitance of a parallel plate capacitor. That is 7. Define capacitance and obtain an expression for the capacitance of a parallel plate capacitor. So please, whenever you hear parallel plate capacitor, don't think of it as capacitor in just parallel. It is talking about, for example, if I have this now to be a capacitor, let's say I have voltage here. So this thing you see here, these are the parallel plates they're talking about. So the space in here can be vacuum, air, dielectric, whatever you want to call it. This can be the negative parts. You can consider this positive part or the negative part, whichever way. But one part must be something, and the other one will be another thing. So if I know this capacitance of a dielectric, sorry, capacitance of parallel plates is simply capacitance of parallel plates capacitor is gotten by relating Gauss theorem to distribution, to symmetry distribution, and the symmetry distribution we are going to be using is surface density, and also relating Gauss law to voltage and charge. And if you remember, I've taught you this is that principle I gave you, which is jerks. I said that these jerks, this G stands for Gauss theorem, which is EA equals to Q over E naught. This is electric potential, and we know that V is related to electric field by ER. R is for distance. Some people like using V, I like using R. I insist on my R. Then charge is given by Q, that equals to CV, and surface density is given by something of this nature, equals to charge all over area. Surface means 2 dimension. But I told you anything density is something over area or length or volume. So surface density is over area. So if I know this, if I make an E electric field subject of the formula here, I will have E equals to Q over E naught A. Now notice that charge right here is equals to Q equals to, because so we have this EA. So if you carry this thing that I have here, comparing the two, now you now have that this is the same thing as saying E equals to replace charge with this. Then you see that E naught A. So I can say, let me choose to cancel these two. If I have a case where I cancel this is why they say sometimes that electric field is equals to surface density over permittivity of free space. And you need to remember that this permittivity of free space is equals to 8.5 times 10 raised to the power minus 12. If you still remember the unit, I don't bother about it because I know that I can still remember it when I try to go back to Coulomb's law. So if I know this, I've noted it. So I now come back because there's something we are trying to do. We are trying to get capacitance of a parallel plate. So we need to relate all these things just as we've stated here earlier. So I now know that if I want to make V now, I can have V to be equal to replace E here. So E is the same thing as saying Q over E naught A, then times R. Somebody wants to tell me that means that V is also equals to, V can also be equals to surface density all over E naught times R. V can also be equals to this. But notice that why I'm not putting this one, I'm not considering this one, is that I want to carry the one that has charge. So, but whichever way, it's still the same. What you have here is the same with what you have here. So if I know this, I can now say from this law, capacitance will be the same thing as saying Q over V. Is it not? Capacitance is the same thing as saying Q over V. So that means that if I know that, I can replace everything I have for V. Everything I have for V, I can replace it in here. So that C now becomes equals to Q over QR divided by E naught A. Remember that everything here is V. So let's do the maths properly. So if I do the maths properly, I'll see that this is equals to Q divided by QR over, yes, E naught A. So I can say reciprocal law is the same as saying if it's division, let the denominator come up. So it will now be reciprocal law times E naught A all over QR. This can cancel this. So that C is equals to E naught A all over R. You need to note this. This is the law or the capacitance of a parallel plate, which means the capacitance of a parallel plate, assuming I substituted, maybe I substituted this, what I have here, as my V, I can still get something. So when surface density is given. So, but you need to note it. Once they ask you, so this right here is the formula or the expression, formula / expression for capacitance of a parallel plate capacitor. So very important to note. So if I know this, let's move to the next question. We're in number 8 now. So number 8 says, deduce expressions for the combined capacitance of two capacitors connected in series be connected in parallel. That's your classwork. You drop that one in the comment section. Now number 9 says the potential difference between the plates of a capacitor is 1000 volts and each plate carries 250 voltage. Calculate the capacitance and the energy stored in the capacitor. So that's also your classwork, because it's the, okay, let me do it. Number 9, let me do it. So number 7, I say number 7, number 8, sorry, is your classwork. Why number 9 says the potential difference between the place of a capacitor is 1000 voltage. So V is equals to 1000 V. And each plate carries 250 micro. So the capacitance is microcoulomb. So when you see microcoulomb, you know they are talking about charge. You might say this video, some things where I'm turning it, bear with me. So 250 microcoulomb, that is charge they are talking about there. 250 microcoulomb is charge that is in microcoulomb. Capacitance is in farad. So they say calculate the capacitance and the energy stored in the capacitor. Question 9 is what I'm reading. So I don't know C. You see that it's very easy. And I don't know E. But since they did not say energy stored in a parallel plate, just the charge moving there. So I can simply say that this is the sentence saying from Q equals to CV, I will have C equals to Q over V. Are you seeing it? I want to use my microcoulomb. The only time you use, if possible, always convert, but me, I don't, okay, let's convert then. So you know that converting is simply times 10 raised to the power minus 6. Everything will now change to coulomb. So when we do, here's my calculator. That should be, so 250 times 10 raised to power minus 6. 250 times 10 raised to power minus 6 gives you 1, 2, 3, 4. So this is the sentence that's saying 2.5 times 10 raised to power minus 4. Okay, so this is going to be the sentence that's saying C equals to 2.5 times 10 raised to power minus 4 divided by 1000. So if you do it, and you know that 1000 is the sentence that's saying 1000 is the sentence that's saying 1 times 10 raised to power 3. So I want to do it this way. So C is simply going to be equals to, that is in coulombs, C is simply going to be equals to 2.5 times 10 raised to power minus 4, yes, then minus 3. So C will be equals to 2.5 times 10 raised to power minus 7. Let's check. 2.5 times 10 raised to power minus 4 divided by 1000. Yes, 1, 2, 3, 4, 5, 6, 7. Yes, I'm correct. So you see, and it's going to be in farad because we already converted. So that's our capacitance. Then energy stored. Energy stored. Energy stored will simply be, since we have C, we have V, we even have Q, anyone we want to use, but let's use that one that is simple, half CV square. So this is going to be just half, that is 2.5 times 10 raised to power minus 7. Then V will simply be 1000 squared. You see that second semester physics is always very simple because they are just focusing on electricity and magnetism only. If sometimes they now add waves, you understand? So I now have 1000 times 1000. Yes, that's like 1 million. Should be, yes, 1 million. So this is going to be the same thing as saying 1 times 10 raised to power 6. 1 times 10 raised to power 6, which is 1 million. So times 10 raised to power minus 7 times 2.5. Yes, divided by 2. So E will be equals to 2.5. Okay, let's divide 2.5 first. 2.5 divided by 2. 2.5 divided by 2. So we have, I'm coming. So we have 1.25 times 10 raised to power minus 7 plus 6, and that is minus 1. So E is equals to 1.25 times 10 raised to power minus 1. Is it not? Yes. So let's do it. Let's confirm. So we do 2.5 times 10 raised to power minus 7 times 10 raised to power 6. Yes. So divided by 2. So it's giving us 0.125, and that is something as saying 1.25 times 10 raised to power 1. So this is equivalent to 0.125 joules. So there you have it. So number 10 and the last one. I'm rushing it. I don't want this video to be up to 1 hour, but you can see. Number 10, to achieve very large capacitance, what variables must be considered in designing the capacitor? To achieve very large capacitance, what variables must be considered in designing the capacitor? That's number 10. So the variables that must be considered. Notice when we did this, here we said capacitance of a parallel plate is C equals to E naught A over R, or over D, over distance, whichever one you want to use. This R means distance. So number 10 question, to answer it, so it's simply going to be you considering C equals to E naught A all over R, and C equals to E naught E R A all over R. Remember that this is the formula we got. Do you remember? So I want you to know the difference. The difference between these two is, this one now is when there is no, like there is no dielectric. But once there is dielectric, this is the capacitance of the plates. And you need to know, if you remember when we started, we said that there is something like ER equals to E over E naught, which means that E is equals to ER E naught. This is permittivity. This is what you mean by permittivity. If you remember, that time we talked about permittivity, where we said something about how free charges move. So then this one is what we call permittivity constant or relative permittivity, or dielectric constant, relative permittivity, or dielectric constant. And this one is what we call permittivity of free space. Free space. And this one is equals to 8.85 times 10 raised to the power minus 12, if you still remember. So if we want to answer this question, the question says, to achieve very large capacitance, what variables must be considered in designing the capacitor? So you will read it up, but first of all, what you just need to know is that as you see this capacitance being directly, this is the sentence saying being directly proportional to E, not ERA. So everything about this should be on the increase. Permittivity of free space should be on the increase. The dielectric should be increased. The area should be increased. Why? This is also the sentence saying 1 over R. The distance, if you reduce the distance, you increase the capacitor. That's what this thing means, inversely proportional. While if you increase the distance, you've reduced the capacitance. So that means that E naught, ER, and area, A for area, should be increased in order for capacitance. Or you know that when we talk about capacitor, it means storage. For the storage, the more area you have, the more charge you can store, in order for the capacitance to increase. Then the distance R should be decreased. But please, when decreasing this distance, you make sure that people that are doing it pay attention, so that they don't do it in such a way that the voltage will be too high for the dielectric you insert in between. So, but it should be decreased appropriately to increase capacitance. So what they just expect from you in simple terms is that whenever they ask you these questions, that you are trying to relate that capacitance is directly proportional to permittivity of free space, dielectric constant, area. They move the same. Increase in this means increase in this. Then this one, a decrease in this means an increase in this. So these are the factors or the variables that must be altered. So everything here, the variables on this end should be increased. These are the variables why this one should be decreased. So in order for us to have increase in capacitance. Thank you. Subscribe to my channel. I'm able to beat the time because this is 58 minutes.